All right. Only see one person. That's pretty. Yeah, I'm recording. We can talk. It's okay, I think. For all the attendees who are listening right now, we'll start the broadcast in just a few minutes as people stream in here. So the chat.
In the chat,
yeah.
Sound is good.
Can anybody, if you can hear me talking right now, can you throw something in the chat room just to say that you can hear me talk? That would be really helpful. We're not getting a lot of good feedback. Okay, good. Oh, perfect. All right, great, excellent. That was an awesome stream of chats just now. And I'll put the slides up in just 1 second. And Megan, you can keep an eye on the chat room while I have the slides going?
Sure.
Okay, great. We're going to give about 2 or 3 more minutes just to let any stragglers come in. Somebody just said, I hope this talk will be rad. I can love that. Can you see the stuff enough? You see some chat messages, right? Okay. Yeah, that works. I mean, I saw that.
That was just to the host.
Oh, okay. Well, yeah, I'll be throwing something on the screen in just a second. For those of you who aren't seeing anything on the screen.
I'm not seeing the group. I'm looking for the group chat. I'm going to group chat to you.
Okay. How many people are here? Does it say? Is it not public? Looks like there are about 53 people logged in right now. people now. One more minute and we'll get started. I want to see if I can allow the attendees to see each other or chat with each other. Is there any way to do that? I'm all alone. I'll try and see if I can make it so that you can see all the other participants in here. Can you make everybody a panelist, maybe? They're trying to make them all panelists. Can you make the exclamation point in that there?
I don't know. Can you ask Jen from whatever?
Yeah.
In the chat.
Jen. Jennifer Mackin. No, some people are thinking they're early because they can't see the other attendees, but everyone is, there are 70 people in the room now, and we're just trying to find a way to let people see each other, but I'm not sure if we're going to be able to do that this time around. I'm going to try and make everybody a panelist, and maybe that will allow this to work. Let's see if this works here. Okay. Do people see each other now? Yeah, we could always jump on IRC. That makes a lot of sense. Okay, people can see each other now. I think I made everybody a panelist. So, does that work? People say yes? Oh, cool. All right. So I'll try and make everybody a panelist who shows up. So they can control the meeting in what sense? Okay, please don't abort the meeting while it's happening right now. That's the only thing I would say. All right, we'll actually get started on this. I trust that they'll get us advertise the meeting, and things should work out okay. So, yeah, I'm recording, and this is being recorded. So, I'm going to share it with my desktop here, and you should be able to see the opening slide, the presentation. Megan, can you see it okay? All right. So this is a brief but hopefully helpful presentation on schema design in MongoDB. And if you'd like to access the slides, there's a URL at the bottom of the slide there. It's all on SlideShare, so if you need to have a look at these later, definitely go do that. So basically what I'm going to talk about is some of the kind of principles of schema design and how those relate with the features of MongoDB. We'll go from there, and I'll introduce myself as well. My name is Kyle Banker, and I work at 10gen. I mainly work on Ruby-related things, but I also do a lot of presentations. And so, yeah, so it's me. So here's schema design. So I think that when we're thinking about schema design in any database system, we have to ask ourselves three. Actually, I think I have 4 questions here actually, and this kind of gives us a sense of what the possibilities are for designing schemas in a database. And so, the first question is, what's the basic unit of data? And most of us are familiar with the relational database and the key value store, right? So in a relational database, our basic unit of data is a row. And, the row is basically defined by the kinds of columns that we've defined for a table. The row is a relatively flat structure. And it limits sort of the kinds of representations of data that we can have in a relational database. And very much the reason why we go for a very normalized schema, well, among other things. But the key value store, our basic unit of data is just the blob, right? It's that blob of data that we throw into the database. And we don't really get a sense, there's no real structure preserved, right? We're just kind of anonymous bytes in that sense. In MongoDB, the basic unit of data is a document. The document is a fairly rich kind of data structure. And I think probably you wouldn't be in this webinar right now if you didn't know what a document was. So I don't need to explain it. And if you don't know what it is, we'll see some examples. But the first question is, what's our basic unit of data? And what kinds of structures does that allow us to represent? The second question that we have to ask with any database system is, what are the features of the database? What does the database allow us to do with that basic unit of data? In a key value store, we don't really have a lot of options, right? We can query basically on a single value. We enter data based on a single value, our key, and we pull data back based on that single value, that key. With the relational database, we have a very rich language called SQL, which gives us essentially unlimited ability to query our data in kind of unimaginable ways and to join our data together in innumerable ways. The question with applied to MongoDB, I think there are a few features of MongoDB that are really important to keep in mind when we're thinking about how we can query and manipulate data. But we do have a pretty powerful query language, so we have dynamic queries. Another thing is that we have secondary indexes, so that when we are querying into the structures of our data, we can do so efficiently and define indexes for the queries we expect to be doing, so that our queries will be efficient. The other thing we have are atomic updates. These are in-place updates, meaning that if we're representing data in a document and we're representing that data in a fairly rich way, we can write operations that go into that document to update particular parts of that document. And I'll explain kind of what that means in a second if you're not familiar with it. But that's definitely a really important feature when it comes to thinking about what kinds of structures are allowed for schemas in MongoDB. And finally, we need to think about aggregation, how we're going to sum up and report our data. Often that's a really easy thing to do in a normalized relational database setting. In MongoDB, things tend to be sometimes a little bit more denormalized, and a lot of times for reporting purposes, you might use something like MapReduce in order to get a certain kind of view of that data later on. So those are some of the features that I think are really important to really understand well with MongoDB when you're starting to think about how you're going to model your data and design your schema. And then you also have to think about the limitations of the system, right? And I think the biggest limitation with MongoDB is that we don't do joins. Now there's a very specific reason why we don't support joins, which is that in a sharded architecture, we don't want to have to communicate between shards. But I think you'll find that not having joins inspires that limitation can inspire a certain amount of creativity, and hopefully I'll show you some examples of that. And then the final question that you need to ask when you're modeling data, once you kind of answer these previous questions of the basic unit of data and what kind of things your database allows you to do, is how do you need to access that data? What's the read? For example, what's the read-write ratio of your application? That can make a huge difference in terms of how you represent your data in MongoDB. What kinds of updates do you need to do to that data? Do you need really granular control over updates, or are you updating kind of a large data structure all at once? Are you only inserting, or are you doing a lot of updates later on? These questions are really important to answer. And then what's the range of queries you need to do on the data? For instance, if you, and we'll talk about this in a second, but if you're storing something like blog comment or blog post comments, if you just need to display those comments in the context of what's being commented on, like in the context of a blog post, then you really don't have a huge range of queries. But if you need to slice and dice those comments in innumerable different ways based upon who commented and comment thereon, then, that makes for kind of a different strategy for how you're going to model that data. So basically, the general kind of, for this first part of the webinar, the idea I want to get across is that when you're thinking about schema design, the first thing to do is to really understand the features of the database, because that allows you to, you know what you can get away with and what you can't get away with so easily. And the second thing is to really think about what your application has to be able to do. So those two questions are important, and I encourage you to just to work on those as you're thinking about designing schemas. But now that said, I do have some general advice, and hopefully give that here in the next part of the webinar. So the very first thing, I think definitely a sweet spot for MongoDB is in rich documents. And what I mean by that is modeling an entity holistically as you can using a single document in a collection. So let me give you an example. What I've got on the screen right here is an order document. And if you've dealt with something like orders before, like for instance in a relational database, you probably normalize this out using a number of different tables. So you likely have a table for line items. You might have another table for shipping addresses. You might have another table that stores a copy of the product as it exists at the time of purchase. So you might have this highly normalized structure, and you kind of pull it all together with various kinds of joins to represent a single order. So this is an example of representing the order as just a single document. And so you can see at the beginning, we have the primary key, which is the underscore ID, and then we have a user ID, linking this order to a given user. So we're imagining, obviously, a users collection and also an orders collection, and a kind of one-to-many relationship between those. And the user ID is basically a foreign key. So, one of the things that I've heard some people talk about when they start MongoDB, they say something like, oh, I can't have foreign keys, right? I have to represent everything in a single document. The answer is no. You can model things in MongoDB in very much the same way as you do in a relational database. So if you want to do something that's highly normalized, or if you want to do something where you use a lot of foreign keys, that's perfectly fine. And the query structure of MongoDB and the kinds of indexes you can define allow you to do that efficiently. So that's nothing to worry about, and that's very common practice. So the next thing we have, if you look at line 20, is we have, and I think I have a nice little circle around here. I don't know if that helps or not. If you look at line 20, we have line items is an array, and it's an array of other objects. So each of those objects represents a product. Now this is pretty highly simplified, but what you have is you have a SKU, and you have a name of a product, and you have some list price. Now in reality, you have a lot more information per product. But just to kind of give an example, right? There is a little bit of a typo in line 28 there. I have a hash rocket in there. Apologies, I was converting from script. But anyway, so you have your array of line items in this document. And then the next thing you have is you have a shipping address. And the shipping address points to an object, not an array of objects, just a single object representing that user's address. And then you can see at the very end, we have some totals, right? So this is kind of a nice, what you can see here is we're representing kind of a singular conceptual entity as a document, as an order. And MongoDB has, the JSON, ESON structure here allows us to represent that fairly kind of realistically, and it's easy to understand. And if we were to pull this information up from the MongoDB shell, we can easily see our order. So the question is, how can we manipulate this? I think, it's one thing to sort of represent a rich document, but the second question is, what kinds of operations can we perform on this document? And can we query this document? So I want to give a couple examples of that. And the first example here, I want to find all the orders with a given product SKU. That's relatively straightforward because, line 72 right there, I'm just defining an index on line items.SKU. So you can see, one of the features of MongoDB is you go to not only define secondary indexes, but also define secondary indexes on nested fields. And so if we go back to the original document, you can see that SKU is this nested field within line items, and yet I can define an index on that so that when I query it, on line 73, when I do db.orders.find, that's an efficient query, and I can easily get the information I'm looking for. somebody's saying that maybe they can't hear my voice so well, so I'm moving the phone a little bit close to my mouth. Hopefully that'll help out. And if anything was unclear in what I was just explaining, at the very end, I'll answer any kind of questions people have. So this example here is finding all the orders in the last week sorted by total. And this is just another thing that we could easily have an index on that created at field, which is not in my original document, but you could easily have that. And you could easily find all those orders, sort them by total and descending, for instance. So, the point of getting it across here is that you can, even if you have kind of data in a sort of rich document, you can query that document relatively easily in MongoDB. Here's another kind of interesting operation, and this is using an atomic push operator. So, obviously you're going to have some kind of add to cart method. And when you want to add to cart, you're going to have to push something into that line items array. So this is an example of basically in a single atomic operation, adding an item to our line items. So right, let's say we want to buy a basketball, right? So we literally push onto the line items array. And you can see that in line 83. We're using the push operator, and we're pushing an object onto that. So there's no need, in other words, there's no need to do an entire rewrite of the object or pull down the object, update it, and throw it back up to the database. We can relatively easily handle that with one of our atomic operators. And that's kind of another argument as to why it's good to use these rich documents. And then another kind of operator that's actually relatively new and some people may not know about, it's called the positional operator. And what it allows you to do is modify an object within an array. So, for example, let's suppose somebody orders a basketball and then decides they want 5 of them or 2 of them instead of 1 of them. What we can do is we can use this special operator. And this query kind of demonstrates what we're doing in line 83, where we're updating and we're trying to find a document that matches a certain ID, and then that also where the SKU matches a certain SKU, and that's basically allowing MongoDB to locate a particular document within that array. And then for the update side of it, we're setting a quantity value to 2. So again, if I go back to the original document, what's happening is that we find say we find the SKU on line 21 there, MongoDB finds that particular document and then sets a value inside that document. What I'm trying to say with this feature is that this gives us a fine-grained level of control over the individual documents within our array. Now, I saw that somebody had a question about whether ensure index is mandatory. No, it's not mandatory that you create an index in order to query on that field. It's just that the query will be a lot more efficient if an index does in fact exist. And then somebody else is asking if push and get are functions. Push and get aren't functions per se. They're basically special operators that the MongoDB server understands. So they're not functions in the sense of a JavaScript function. But basically what we're doing when we do an update, for instance, is we're giving it a document, right? And so if you can see, if you look on line 83 at my example with the positional operator, I'm giving that update function 2 arguments. The first argument is a document that's specifying the query. In other words, that's finding a particular order in our collection. And then the second document begins with that $set operator. That's actually, it's just a document, right? But it's defining a particular operation on the order that we find. So hopefully that explains kind of whether those are functions or not. Okay, so, and then one final thing about using documents, you're going to want to do different kinds of aggregations on those documents. And that's one thing that may be a little bit more difficult about having that slightly more denormalized model. So, one of the recommendations that I usually give people is that they learn how to use MapReduce, because this basically gives you, unlimited ability to group and aggregate over documents, basically in any way that you need, because you're simply writing JavaScript. And so in this example right here, and I'm not going to go through the details of it, you can definitely look at it much more closely when you download the slides, but basically what this MapReduce operation does is it outputs total of orders per zip code. And so, you know, in the first case, I'm just defining a function. Nothing's happening on the database for the map. I'm defining a reduce function, and then the actual operation on the database is on line 61, where I do db.orders.mapreduce, and I'm passing the MapReduce functions that I just wrote to that method, and then I'm specifying a collection to for the results of that operation. So that's basically how MapReduce. Well, that's one of the things you can do with MapReduce, and I definitely recommend if you're going to do this kind of rich object-style model, you learn how to use MapReduce so you can do different kinds of aggregations for yourself. Does MapReduce use an index? MapReduce does not use indexes, no. So one thing you can do with MapReduce is you can pass it a query which can use an index to filter out results that you wouldn't be iterating over in the first place. And so that can make MapReduce a little bit more efficient. And if, for the person who asked about indexes, if you're worried about kind of the efficiency of MapReduce, a lot is being done to make it even more efficient. And that's definitely something that we can talk about offline if you're more interested in that. So one final example I wanted to give about rich documents, because I think it's a good case study, and it kind of gives another one of the reasons why rich documents are valuable. This is an example document from a site called wordnik.com. And what Wordnik did really relatively recently, they're this kind of Web 2.0 dictionary site. And so they index lots and lots of words out of the English language. And they have all sorts of kinds of definitions for each word and dictionary sources and examples. And, you know, you can imagine kind of the richness of a single entry. And originally they had a MySQL model, which was relatively normalized. And what they've gone to instead is the model that you see here. And this might be a little bit hard to understand. This isn't necessarily the best example, but this is one of the examples they gave me. And this is actually the definition for the letter M. So it's the first entry in the M part of the dictionary. And basically what they're doing is that they're taking the rich properties of a document and they're embedding kind of a lot of information about that. So you can see kind of toward the bottom, there's an array of definitions. In the middle, there's an array of different syllables within the letter. So this is something that lends itself really nicely to the structure that MongoDB gives you. And then the other really great thing about this, you know, from moving to a really normalized model that you have in a relational database, something like Mongo, is that they got a huge bump in query performance. So their queries took something like a quarter the amount of time that they took with a relational database. You can imagine the kind of complexity that's involved in taking a highly normalized model and joining everything together on the server side before you pull it back to be able to display it. In this case, you have everything represented in a single document, and so the query to the database, I mean, the amount of computation the database does is greatly reduced. So using a rich document when you can, kind of in summary, using a rich document when you can is ideal, you know, for read cases. And if you can find ways to use some of the features of MongoDB to update that document in different ways, especially using atomic update operators and to aggregate over that document with MapReduce, I think you're going to find a lot of big wins. Okay, so the second piece of advice that I have regarding data modeling is to simplify trivial relations. And what I mean by trivial relations are relationships that when you were using a relational database would basically consist of a single table with just a few columns. And so let me just give you an example. I think tags are a great example. And so in this case, we have a sample link from a link sharing site. And the document basically consists of a title, a URL, and the tags for that entry. And here, so my tags are simply an array, right? So my tags are MongoDB, schemas, data modeling, and denormalization. And in a relational database, I would probably have a tags table. You know, that's relatively simple, right? I would have a tags table, and that table would have some foreign key to the object being tagged, right? Or, you know, there are a few different ways to represent it. You might also represent it with some type of join table using some type of many-to-many relationship. So there's a couple ways to do that. But it's a relatively simple entity, a tag, and that's something that can really be nicely represented in a single document like this. And the great thing about these array values in MongoDB is that they can be indexed. And so you can see on line 132, I'm ensuring an index on tags. And so what that allows me to do is a query like this, where, and pardon the at in front of the links, but a query like this where I can do, pardon the Ruby, a query like this where you can do links.find, and I'm finding all the links which have a tag of schemas that contain that word. And that's going to be, that query is actually going to use an index. And so these array keys tend to be really powerful in MongoDB. And we've seen a lot of people in their data modeling find that kind of removing those small relations and these tables that contain very little data and throwing them into an array key like this works pretty well. Another example that's kind of similar is modeling votes. And so, suppose you're doing up votes or down votes, or on a similar kind of site, a link sharing site. So you can see I have an example post document at the bottom of the page here, and the post contains just the ID, the primary key, and obviously a lot of other information about the post, but I'm just focusing on votes. And so actually, sorry, somebody's just letting me know there's actually a question. One of the problems with screen sharing in this way is I can't see the chat very well, so I'll definitely answer all your questions at the very end. But somebody asked a question, what if I don't ensure an index? If you don't ensure an index in the tags example, then the query will still work, but it won't actually, the query will still work, but it will not be efficient at all. So you should definitely ensure an index if you expect to be doing those types of queries. So back to this post example, we have basically an array of people who have voted on a particular post. So that's on line 225. We have an array of those object IDs are just primary keys of user documents, right? And you could also use username there if that were unique across the system. But I'm just using object IDs as the primary key. And I'm also caching the number of votes just for display purposes. So I don't have to, when I'm pulling back down the post, I don't have to calculate that value or call size on that value each time. So that's an example of kind of storing the voters. Now, the question is, how do you update? Well, okay, let me just back up for a second. How would you represent it in a relational database? In a relational database, you'd have some kind of voters table which contains, a user ID and a post ID, and you would query that table to make sure that the user hadn't voted on this particular item before and add an entry to that table. In this case, we can store all the voters just in the object itself. So again, kind of looking at the features of MongoDB that make this kind of data model make sense, you can look at the query that I'm setting up right here. And basically, on line 225, I'm defining a query. And the query says this: find me a given post. So find me a post with a given ID. And that's really straightforward. But then the second part of the query says, and make sure that post doesn't contain a particular voter ID, right? Because we only want the query to succeed if that voter hasn't yet voted on that post. And so on line 227, we're defining an update. So if the query succeeds, then the update we want to do is we want to push, again, we're using that special atomic operator that MongoDB provides for us, but we want to push that voter ID onto that voters array, right? And then we also want to increment the number of votes by 1. And so, once we've defined those, and, we're just defining a couple documents there, then we actually send it to the database. And so on 230, we are doing an update, and we're giving it the query, and we're giving it the update. And that update is going to be atomic and succeed only if that voter hasn't voted. And so what you get is in a single, relatively simple operation, you can upvote an item. And so again, like this can make a lot of sense in this situation. And I'll look at some of the questions at the end, because I can see that some of the questions are kind of complex. So another example, finding all votes for a given user. We've seen something similar already, right? We want to ensure an index on the voters because that contains basically user IDs, and then we can just do db.post.find, and then that will impact all the posts. And then the other thing we can do, and I didn't throw it into my example here, but we can actually just select we could, if we wanted to, just select the votes array if we wanted to, but this just gives us all the posts that the voter has voted on, and does so in an efficient way. So those are kind of what we were just talking about are relatively simple relations, and those are the ones that I highly recommend for a more kind of the more denormalized approach that you see there, because I think that the features of MongoDB warrant it. But you're also going to have cases where you have more full-fledged style entities that you need to relate to one another. And so I'm going to talk about kind of modeling typical relations in this case. So, you know, the example that we often give is one of the posts, like a post and many comments. And you can do this in a number of different ways. But, okay, typically in a relational database, you'd have a post table and a comments table. Comments would contain, you know, post ID and user ID and various other types of attributes that would allow you to preserve the tree-like structure of comments. That's kind of a very standard way of handling this. In MongoDB, there's a few different ways you can do this, and I'm going to start with the more kind of embedded style way, right? And so in this case, I'll call this an embedded document. And so we have, you know, this is a post document, and the only post attribute it actually contains is title. And then we have a comment attribute, which points to an array. And that array itself contains objects. So we've seen something similar to this before, like we did in the line items example. But we would obviously have a little bit more information per user. But what you can see here is that we're storing within the comment objects themselves, we're storing the text of the comment, the username. We probably also store things like date. One of the things I want to kind of show here is that we're storing the actual username. One of the things we're going to have to do is display the username. And so you kind of have to ask yourself a question as to whether, you know, whether you store the username, you know, some people would say redundantly, within that inner object. And I think, you know, a lot of people who are using MongoDB are doing that. They get a big win out of that because they don't have to do a second query. But you know, obviously there is a case for, you know, if you had a more normalized model, then you have to do another query. And since MongoDB doesn't do joins, you can't just join that other query. So that's something to keep in mind. But this is a very common kind of pattern for a simple relation like this. And obviously, we're not just talking about posts and comments. We're talking about any kind of one-to-many relationship where both entities are relatively fleshed out types of objects, not just something as simple as a post, right, but a real post and a comment. And, you know, just to show kind of another feature of MongoDB that I think is relevant here and that's relatively newly added, we have an operation called slice. And so what this allows you to do is when you find a particular post, you can grab only, you know, suppose there are 100 comments, you know, on that post within that document, and you only want the first 5 comments or the last 5 comments. These two examples are showing you a way to only pull back those comments. So again, kind of thinking about the features of MongoDB that make these different data models viable. This is definitely pretty useful in this situation. So the second way to represent the data, which is very, very similar to the first example, is an embedded but also nested document. And what this means is that I'm literally representing the tree structure of the comment within the document itself. So you can see we have our title, and then we have comments, but the individual comment objects are themselves capable of containing comments, right? And so we have comments pointing to a username, the text of the comment, and then that comment itself containing comments, which also leads to a username and the text and the comments. So, you know, if, you know, this is useful if you don't really want to have to do any kind of application side processing of your data, and you essentially want a cached view of some structure. And so, you know, obviously, like, there's very little processing that has to be done to represent that tree-like structure. You're storing the tree-like structure within the document itself. The downside of it is it's a little bit more, it's actually a lot more difficult in some cases to query for different kinds of comments. So you find that you lose a certain amount of flexibility. That said, some of the people who are using MongoDB for posts and comments are using this actual structure. It actually does work well for them. So it really does depend on the use case. But this is kind of another example of a way you can represent those types of relations. And then finally, you can go normalized. And there's absolutely nothing wrong with going for a more normalized style representation in MongoDB. So you could have a collection of posts and a separate collection of comments. You can have foreign keys inside the comments collection, and and that's fine. There are definitely some advantages to that. One of the disadvantages, you don't get your queries might not be as efficient. You have to do more than one query. You have to do a little bit more processing or a slightly more complex query to pull out the given comments for a post. And I'll come back to kind of that in a second. But to talk about the kind of use cases of these three patterns that I've just described, for an embedded document, you want really fast queries because you can get the entire object in a single query. And if the embedded or if the many documents always appears as its parent, then the embedded document approach makes a lot of sense. And likewise for the embedded and nested documents, but the only kind of other advantage being in that case that you can represent a complex hierarchy and essentially have that a cached representation of that in the document. That can be a good idea. But finally, the normalized representation will give you a little bit more flexibility. It'll simplify different kinds of global updates to the comments. But when I talk about the maximum flexibility, I mean the maximum querying flexibility. Because, for instance, at the moment, one of the things you can't do with MongoDB if you're doing the embedded representation is you can't say, like, give me the latest 5 comments across the entire system. That query is actually a little bit difficult in MongoDB at the moment. So you need to work with comments a lot on an individual basis and query them in a lot of different ways, and you're going to want to go with a more normalized representation. So let's talk quickly about a many-to-many relationship. The typical way to do that in a relational model, you have a join table. In MongoDB, people typically don't do join tables. I haven't seen a lot of people using join tables. Instead, what most people are using are array keys in one way or another. Let me give you an example of that. So here's a common many-to-many relationship where we have products and categories. And this is, of course, assuming that your category representation needs to be relatively rich. If your category representation were super simple, you might consider doing it in the way that we represented tags a little bit earlier. But in this case, what we're doing is we're representing the relation on both sides. So in the product, in the sample products there, on line 89, you can see that we have an array of category IDs, and then in the category, you can see that we have an array of product IDs. And if we're going to do this, we would also want to have an index on category IDs and another index on product IDs, so that queries on those fields could be very efficient. And the nice thing about this kind of dual approach, and this, what is definitely a more deformalized approach, is that what's nice about it is that your queries are really simple. Because, since MongoDB can clear that array field, you can see that finding all the categories of a given product is as simple as what you see in line 102 there. Using categories that find where the product ID matches this product ID. And likewise, the query is exactly the same in line 105, just the other way around, to find the opposite, find all products in a given category. So that's one way to do it. Obviously, one of the downsides is that you have to write into 2 places when you make modifications to product category ownership. But again, that's not a terribly expensive operation because in MongoDB you typically use atomic operators to accomplish that. But if you don't like the more denormalized approach, you can also just represent kind of one side of the relation and still get roughly the same functionality. So in this example here that I have is a product, and I have an array of category IDs. And then I also have a category, and I'm not storing the product IDs. And so in the example queries down here, if I want to find all products in a given category, the query is the same as what we saw before. But if I want to find all categories of a given product, I actually have to do 2 queries. Okay, the first thing I have to do is I have to grab the product, and that's what I'm doing in line 194. And the second thing I have to do in line 195 is I have to do an in query. So I have to give you that category that find where the ID is in some other array of IDs, and that will allow me to do that. So for people who don't like having to update in 2 places, this is another option for doing a many-to-many relationship. So again, MongoDB, many-to-many relationships, we don't really do joins. We typically use indexed array keys, and that seems to work well for a lot of situations. Okay, so just a couple of exercises for the viewer, because there's a few other kind of items that are just worth exploring on your own. People often ask about trees, and we actually have some pretty thorough documentation on representing trees in MongoDB. And there are a dozen ways to do it, and it really depends on the use case. So if that's something that you need to represent, I highly recommend having a look at that documentation. Another time, a lot of times people need to represent stacks, queues, those types of data structures, and represent them and work with them in an atomic sort of way. And we have a command called find and modify, which if you're not familiar with it, will allow you to do an atomic update on a document and return the document in the same operation. So there's quite a bit of flexibility in what you can achieve with that. And so for those situations, I definitely recommend having a look at the find and modify commands. And finally, this is sort of a plug, but we definitely want to get kind of a database of patterns that works for people. And we have a cookbook site that we just started, cookbook.mongodb.org. It was actually inspired by a similar site done by the Reddit folks. But you can fork it on GitHub, and hopefully we'll have more of a catalog of these types of patterns and kind of real-world schema design / data modeling situation. So I definitely encourage anybody who's interested to help contribute to that. So that's most of the material I have for this presentation. And what I'm going to do right now is kind of have a look at some of the questions that people have entered inside of the chat box here, and hopefully answer some of them. So just give me 1 second. Okay. Somebody asked, Rodrigo asked, I see that most of your talk relies on the denormalization, on the denormalized power of MongoDB, but can't that be achieved using a relational database as well? Isn't normalization used to deal with duplication of data? So I guess the one comment I'll make about that is that certainly you can denormalize in a relational database, but one of the big differences, there's a couple big differences. One of the differences is that documents are much can represent data in much more depth than a row can, right? And so in the example that I showed before of the order, if you're going to represent an order in a single row in a relational database, you'd have a whole bunch of columns that weren't organized in any particular way. You'd have shipping address, city, shipping address, state, shipping address, a zip code, and then you have how would you represent all the different line items? That would be actually really hard to do unless you were to use some sort of blob structure, in which case you would lose any of the query power that you'd have in that relational situation. So the big difference is that the MongoDB style document allows you to kind of organize that representation in a much more coherent sort of way. And also because you can index things like arrays and query kind of those inner arrays, you get a lot of query power in that case. So I guess that's some of the decent answer, and definitely, Rodrigo, if you'd like to talk more about that kind of offline, I'd be happy to talk about that in more depth. We'll look at some of the other questions that we have in this case. How the performance work with 10,000 votes, and when I have to deserialize the object of all voters' IDs to get the count. So in that case, with 10,000 votes, you would probably, so you wouldn't have to you could pull back the count just by specifying the count field, right? So when you do a query in MongoDB, you can specify the fields to be returned. So if you just want to return the count field, you can do that. You can have to deserialize the entire object. And the second thing, how would I deserialize? If you do expect to have like thousands and thousands and thousands of votes, there's a 4 megabyte limit on documents, so you do have to kind of weigh a trade-off there. If you're talking about a typical kind of social news site like I was giving an example of just now, then it's not a huge deal to store all of those in the document itself. And I think for most use cases that's going to be fine. But if you're expecting 10,000, tens of thousands, or hundreds of thousands, that's a case where you might want to go with a slightly more normalized approach. So thanks to Kathy on that question. Is ensure index needed after every update? No, ensure index is only needed to define an index on one or more fields. And that basically, if you're going to be doing anything though that uses it as a query, you're going to want to make sure that there's you don't want indexes on every query, but on queries that could be expensive, you definitely want indexes in those cases. And you can find out whether your queries are expensive by performing explains on them. MongoDB has an explains function, and so I definitely recommend looking into that. Obviously, like deciding what kinds of indexes you're going to have is very app specific, and there's a lot of kind of empirical type of work that's required to figure out what the ideal indexes are for any given application. Somebody says, I'd like to see how all this works in Ruby. All this works exactly the same in Ruby. You're just using Ruby hashes to represent the data structures instead of JSON. And obviously, one of the things about using some of these different programming languages, people have built out these sort of ORM style layers that allow you to represent relationships. And what they're doing in a lot of cases is just a lot of the patterns that I've shown you here. But one of the advantages of kind of looking at it on a slightly lower level like we're doing here is that you can sort of think about the patterns yourselves and your use cases and determine whether, how best to model that data yourself. And I highly recommend kind of doing the work to get to that point because you're going to end up with a much more optimized application. And another person kind of asked about thousands of items updated in bulk, thousands of items existing in an embedded array. Kind of same question. You don't want to get too many. You'll probably want to go for a more normalized approach eventually if you're going to have millions of items, for example, inside of an embedded array. Somebody here is asking, Pablo is asking if there are any locking mechanisms. MongoDB isn't, there aren't any locking mechanisms in the sense that I can initiate a multi-object transaction and put some kind of lock on an object. However, you sort of get around that by being creative with atomic operators. That's definitely a big discussion, but there are a lot of examples, in our documentation. And if you have kind of further questions about how that would work or a particular use case, we could definitely talk about that. Having a little bit of trouble reading through this chat room, but I'll get into more. Somebody's asking if embedded arrays are in the 4 megabyte size limit. Yes, they are. The entire document is counted within that size limit. How often do you have to use ensure index? You only have to do it once. Once you call ensure index, the index will be created. You can call it any number of times, so it's kind of an idempotent operation. Somebody's asking why there's a 4 megabyte limit on documents. Well, one of the reasons is that when you're pulling data across the wire, when you get above 4 megabytes, you can saturate the wire, if you're pulling back these really huge documents. And yet another reason, if you look at languages like Python, Ruby, or really any language, you have to deserialize documents from their native ESON representation. And so, if you're deserializing 4 megabytes at a time, that can put a lot of load on your application. So you wouldn't want to have too large documents. That said, when you have large documents, it is important to be judicious about which fields you're pulling back. And so definitely take advantage of the fields feature so you can specify which fields of the document to pull back. What are database references, and are they required to be stored in DB references in your document? No. Database references are just a convention that may be iterated on later, but all a database references is a document within a document specifying essentially a foreign key and the name of the collection that the foreign key is linked to. That's usually not necessary. So usually your application is going to know which collection your foreign key is linking to. So personally, I don't actually use DB refs a lot, but for people who like that kind of convention, they can use them. Okay, so another question from Rodrigo. On data duplication in column names, from the box size experience, they realized that the column name size has a huge weight on the storage side, making them reduce the name of columns to 3 letters that ended up reducing the size of their data in a couple of days. Does MongoDB have an idea of how to reduce the impact of column name size in the future? Yeah, obviously column name size is going to have an effect if you have millions of documents, which Bauxite says. They're essentially a logging application, right? And so they're logging just lots and lots of server data, every second. And in those situations, it makes sense. I think for more common applications, which aren't going to have this flood of data, it will make less of a difference. But as far as I know, for the moment, there are no plans to, for example, abstract out the column, or not the column name, but I guess the key name is actually the proper word to use, because each document is, defines its own schema all by itself. So, in a sense, to abstract that out, to go to a more kind of rigid relational type of structure, which is something we don't want to do. So, obviously there are certain types of optimizations that you could perform, but as far as I know, no work is being done on that at the moment. Is pushing data into the database directly to disk much less resource intensive than hitting the server? I don't quite understand that question, Dan. Maybe you can elaborate on that. Are there any admin tools for MongoDB like PHPMyAdmin or MySQL? Yes, there are probably a half a dozen admin tools for MongoDB right now. If you just Google for it, I know that a few people have done blog posts on the available tools, and if you can't find it, definitely hit us up on IRC. Is the insert of a new document which contains embedded documents atomic? Is the insert of a new document which contains embedded documents atomic? I've seen that there's atomistic sure that's the operation, but it's unclear whether this applies to initial insert. I don't quite understand how an insert. I don't quite understand the question. I mean, insert. It makes sense for an update to be atomic. Because you have the possibility of more than one process in updating the same document. As far as an insert, to me that makes a little bit less sense unless you have a situation where you have like a unique index on a field, in which case that is, I guess, you can sort of consider it atomic because it's going to fail if it doesn't satisfy the index. Could you elaborate on data schemas that need some kind of reporting? What would be the best approach schema-wise? Having a hard time understanding that. I think the best advice I could give without further details would be to kind of familiarize yourself with the way MapReduce works and the kinds of operations you can do with it, and see where to go from there. Can you speak about materialized paths? Materialized paths are a pretty nice technique for representing tree structures. And you can index them, and the nice thing about them is that you can use regular expression queries to find particular subtrees represented therein, and those can be efficient because they'll use the index. So if you look at some of the documents that we have on trees, you can see how materialized path works. Yes, so somebody said, dumb question, are embedded documents in the Mongoloid Mongo Mapper world are in fact just kinds of embedded arrays? Yes, that's all they are. They're just embedded arrays. Although actually they're represented, I know that in Mongo Mapper they're represented in two different ways. You can actually have an embedded document that's literally embedded inside. Yeah, I'm sorry, I take it back. Embedded documents are just an array of documents, yeah, in the way that I'm showing in the presentation. And that kind of goes to show that, for people who are using these sort of object mapping type layers on top of MongoDB, it really does pay to understand things on a slightly lower level, because then you can sort of see what's happening under the hood, and you'll write better code, and you'll build better applications. So it's about 5 o'clock now, so I think I'm going to go ahead and wrap up the presentation. I would be happy, I'm on IRC at kbaker, and I'd be happy to answer any questions in more detail. We're also available on MongoDB user, which is a Google group, and you post a question to MongoDB user or a potential schema, you'll get an answer very quickly usually. So thank you for all these 70, I think I saw a total of 80 people in the chat room at one point. Thank you for attending, and I will throw back in the link to the slide. So appreciate all you attending, and definitely hit us up offline, an IRC. Really appreciate it. Thanks a lot.